first part of the semester was all about how points move. So we talked about where, how, and why points will move. And now in the last part of the semester, we're going to talk about rigid bodies, so things that actually have size and shape. And when we start doing that, we can think about big objects as moving in two broad categories. They either move in translation, so the car was here, now the car is over there. That's just translational motion. And we also have rotation. So it was facing this way and now it's facing that way, sort of rotational motion. We can combine these two things together to explain any motion that happens whatsoever. And so that's what we're going to do the last part of this semester. And we're going to start by sort of digging into how these things are related. And I want to start with two definitions that we already know, but I'm going to give them another variable name. And that's just to keep up with the textbook. The first one is angular velocity. We're now going to call this omega. It looks like a W, but it's actually an omega. And we're going to define omega as theta dot. So the change in angle with respect to time. We could also say this is d theta dt. We've already used this in the first third of the semester, and we're going to come back to it now just with a new name. So I'm not actually sure why the book does it. We're doing it with a new name. And angular acceleration is now alpha. It's a lowercase Greek letter alpha. And alpha is theta double dot. Or we could say d omega dt. So a couple little definitions. We're going to use these a lot in the rest of the semester. So this is a little bit faster way to write them, is as omega and alpha. So looking forward, we're going to be looking at combining translation and rotation to describe the motion of any object in space.